So we are going to determine the products. And calculate the mass of the, do you guys remember what it means when we write PPT? That is the
Precipitate.
precipitate, yes, and that is the solid formed in a double replacement reaction. Okay, so we're going to determine the products and we're going to calculate the mass of the precipitate. That is formed when 177.2 milliliters of 1.25 molar, capital M molar, Na2CrO4 sodium chromate, aqueous, is mixed with 250.0 milliliters of 1.25 molar AgNO3, silver nitrate. Okay, so if we take a look at this question, we have both volume and molarity for sodium chromate. And if we have volume and molarity, we can find moles. Always. Because volume is liters, okay, or milliliters, and molarity is moles per liter. So you can always take your liters and multiply by moles per liter and you'll get moles. And we also know the volume and molarity of silver nitrate. So we know volume and molarity for silver nitrate, so we can find moles. And what that means is we know moles of, we're going to be able to find moles of two different reactants. We have moles of two different reactants, or at least we can find it with a little calculation. If we have moles of two different reactants, what kind of problem is this? If we have moles of two different reactants, what kind of problem is this?
Sorry, two different reactants?
Yeah, we have moles of two different reactants. So what kind of problem do we have when we have moles of two different reactants?
We need stoichiometry.
We need stoichiometry, but even more than that, it's a special kind of stoichiometry. Well,
Solution stoichiometry.
It is, but we've got two different reactants. And if we have two different reactants, the sodium chromate can make a certain amount of product. The silver nitrate can make a certain amount of product. How do I know which one is the actual amount of product?
Isn't the thing we did last class? It started with a C. I don't remember what it's called though. It's like
limiting reactant?
That too. That's the.
Okay, this is a limiting reactant problem. So anytime you have two different reactants, it's going to be a limiting reactant problem. And do we remember the steps to solving a limiting reactant problem?
Calculate both. Find the math, like do the problem, but do like I'm not sure how to word it, but like just do both calculations of the like calculating precipitate with the 177.2 milliliters and 250.0 milliliters, and determine which one makes
Yes.
the smaller one.
Yes. Find the moles of product from each reactant.
It's slightly too long, like I said.
That's okay. I like it that you're putting yourself out there. It's great. Moles of product that could be made from each reactant. And in order to do that, we're actually going to need a reaction here. So we're going to take a look at our two reactants and see what product we get, because we need to identify the precipitate. So let's take our two reactants. We have Na2, CrO4, and that is aqueous. And we're going to put that together with AgNO3, which is also aqueous. And what kind of a reaction is this? Compound plus compound.
Double.
That is a double replacement. Yes, absolutely. So the Na is going to get together with the NO3. So we have Na, which is positive, NO3, which is negative. So our formula is NaNO3. And our chromate is going to get together, oopsie. Chromate is going to get together with silver. Silver is +1. Chromate, you can look that one up, it is -2. So that's going to be Ag2CrO4. So yeah, absolutely, we need our balanced equation. We're not balanced yet. So we need to have a 2 to get 2 silver. And let's see, have I missed anything? Yeah, that's going to mean we also need 2 nitrates, and that'll give us 2 sodiums, and I think everything is good. Now, out of our 2 products, we've got 2 products, NaNO3 and Ag2CrO4, we need to decide who is the precipitate. Okay, so we're going to decide who is the precipitate, because that's what we want to find the mass of. What do we use? What tool do we use in order to know who is the solid? Do you guys remember? Where do you look?
Your data booklet.
Yeah, you look in the data booklet. Okay, and that's, I think it's on like page 5 or 6. Let's just pop down here. There's our data booklet, and you want the one that is the solubility of common compounds in solution. And the 2 compounds we were looking at was NaNO3 and Ag2CrO4. Now, if we look, all of our alkali ions, including sodium, those are always soluble. What does it mean to be soluble?
It's like dissolved in like the water, meaning it's
Yeah,
aqueous.
it's dissolved, so it is aqueous. That is not our precipitate, okay? So that means that this one, which contains sodium, and in fact, it also contains nitrate, which is soluble with everything. That means that one is going to be aqueous. And chromate actually is not on this table. If you go looking for chromate, you're going to be out of luck. However, we are told that this does form a precipitate, and if the NaNO3 is not the solid, Guess what that means? Silver chromate has to be the solid. Okay? So we will pop back to, there we go. Okay. So that means that this is aqueous and this is our solid. And we are trying to find the mass of the precipitate. And this right here is our precipitate because it is the solid. So let's find moles of the product. In this case, it's going to be the precipitate, the Ag2CrO4, that could be formed from each reactant. So, moles of Ag2CrO4, and we're going to do that from reactant A. And we're going to also find the moles of Ag2CrO4 from reactant B, which is the silver nitrate. Is that in the periodic table booklet? Yes, it is. AgNO3. Okay, so silver chromate, or sorry, sodium chromate. Let's go see what we know about our sodium chromate. We know that we have 177.2 milliliters of 1.25 molar. So we have 177.2 milliliters. Oops, I want to make that into liters. 0.1772 liters, and that's of our Na2CrO4 solution. And it has a concentration of 0.25 moles Na2CrO4 per liter. So now we're going to know the moles of Na2CrO4. Now we want to find the moles of product. So cancel the moles of Na2CrO4 and find the moles of product. And remember, we're going to choose to find the moles of the precipitate, which is the Ag2CrO4. Okay, and that gives us, oh, let's see, we've got a 1-to-1 ratio because there's no coefficients there, so it's a 1-to-1 ratio. And we get, let me see, 0.2215.
Wait, hold on. Did you say what? Did you say 1.25 moles per liter?
Oh, did
Go
I do
back.
the, hang on. Oh yeah, I did it wrong. Sorry. I forgot a 1.
And what was the amount of milliliters for silver nitrate?
The amount of milliliters per silver nitrate?
Yeah, I lost track of where I was going.
Don't even worry. The amount of milliliters of silver nitrate is 250.
All right, thank you.
Okay. Okay, so where did we get to? Oh yeah, so here we are. So that's going to be 0.2215 moles of Ag2CrO4. Let's do our second one. And Aries had just asked how many milliliters did we have? We had 250 milliliters, so it's going to be 0.2500 liters of our silver nitrate, AgNO3. And the concentration was actually the same. Makes it easy to remember. It was also 1.25. You notice I made a boo-boo up here. I wrote 0.25, but I should have written 1.25 moles of silver nitrate per liter. And we want to find moles of the product. And again, that's going to be our precipitate product. So that is Ag2CrO4. Okay, and we're going to cancel out 1 mole of AgNO3. And I'm just randomly writing down numbers. I didn't even look at my balanced equation, so I probably did it wrong. In fact, I did. There should be a 2 in front of the AgNO3. So that should be A2 down at the bottom there. Okay. How we doing so far?
Spence,
Yeah.
I'm like super confused.
Okay.
Okay.
I'm going to make everything smaller so we can see the whole picture.
Okay, that's very nice. Thank you.
Okay. So what we have is we have 2 reactants. We have our sodium chromate, which we'll call reactant A. Okay. And we have our silver nitrate, which we will call reactant B. Is that part okay?
Yeah, I kind of
Okay.
at the beginning, so I guess that's why I'm confused.
Yeah, that would do it. Yeah. Okay. So what we're looking at is we're looking at a limiting reactant problem, and the reason it is a limiting reactant problem is because we have 2 different reactants. Reactant A, we know the volume and the molarity, so we'll be able to find its moles, okay? And we know enough information about reactant B to be able to find its moles. We know its volume and its molarity, okay? And if we have 2 different reactants, it will be a limiting reactant problem. And anytime we have a limiting reactant problem, our first step is going to be to find the moles of product that could be made from each reactant. Okay, so that's going to be like reactant A, which is the Na2CrO4, and reactant B, which is the AgNO3. So volume times molarity will give us moles of sodium chromate, and use stoichiometry to find the moles of your precipitate. That's the one that formed the solid. And volume times molarity of the silver nitrate will give you moles silver nitrate. And then you use stoichiometry again to find you the moles of silver chromate. And in this case, we get a different number. We get 0.3125 moles of silver chromate.
So right now you're just trying to find which one the limiting reactant is.
Exactly.
Okay.
Okay. Because we want to figure out how much product we get, but in order to do that, we always need to know who limits the amount of product. Okay, so who is our limiting reactant here?
Na2CrO4.
Na2CrO4 is our limiting reactant, and that means that the most product we can get is that, okay? We can only get this amount of product, this many moles of product. Okay, and if that is the case, then we can take that and we want to find the mass of the product. Well, that's straightforward enough. We know how to go from moles to mass. So if we want to find the mass, this is the,
Hold on. Wait, hold
yeah.
on. So going back to the moles up
Yep.
here.
Mhm.
So the only thing we need to find it, the only thing we still look at the small amount. Is that it?
Yep.
Just like based on moles, that's it. Like the smaller amount of
Absolutely.
moles.
Absolutely.
Got it. All right, that makes it
Okay.
much easier.
Very, very cool. Okay. So then we can find our mass of our silver nitrate. Why am I putting brackets? There's no bracket. Ag, and it's not silver nitrate, it's silver chromate. If I make a lot of mistakes today, it's because I've been awake since 3 this morning, like a crazy person. Don't ask me why. I don't know. So we can make at most 0.2215 moles, and then we can calculate the grams of silver chromate using the molar mass, which someone has been kind enough to do for me. Yes, this lesson will go on YouTube. Absolutely. 331.7. And now I need to pull out my calculator, and we get 0.2215 times 331.7, and we get 73.47 grams of silver chromate. Okie dokie. And that's it.
Miss Benz, I have a question.
Yes.
Can you tell me how to find the precipitate again? I forgot.
Yes, absolutely. So how do you find the precipitate? First, you predict your products. Okay, so I'm just going to zoom in on the reaction right now. Okay.
Okay.
So we zoom in on our reaction and we look at our two products. We have NaNO3 and we have silver chromate. So you are going to go to your data booklet, okay? And we're going to look up those combinations of ions. So let's go look at our data booklet, okay? And we are looking for the combination of Na with NO3, and we're going to try and find out if that's aqueous or not, and we're going to look up the combination of silver and chromate, okay? And this, if you're wondering, is on page, let's just see, it's on page 5 of the data booklet. And if you have left your data booklet at school for any reason, I'll post one of those in our files. So if you go to our team at the top of the page, so if you go to the team, at the top of the page, there's a tab that says files, and I will put our entire data booklet in there, okay?
Okay.
Yeah. So if you're like, oh no, I don't know where mine is, it will be there for you. I would attach it to the assignment, but I've already posted the assignment and it doesn't let you change anything once you've posted it. And it also doesn't let you have more than 5 attachments, which really irritates me, but you know, Microsoft, what can you do? Okay, so once you are here, you're going to look and you're going to see, is something soluble? If it is soluble, that means it's dissolved, which means it is aqueous. Okay, so that's like, you know, if you take table salt and you stir it into the water, it dissolves. It's aqueous. But if you were to take something like chalk, okay, which is calcium carbonate, okay, like, you know, even if it rains, it might wash away the chalk if some kid's been drawing on the sidewalk, right? But it doesn't actually dissolve. It just kind of, the particles just, you know, get dragged away by the water. And so if we were to look up carbonate, for example, okay, so here's carbonate. Unless it's with your alkali ions, which are lithium, sodium, potassium, rubidium, francium, okay, or H or NH4. If it's with any of those, it is soluble. However, calcium is not, an alkali. It's an alkaline earth. And it's not hydrogen. And it is not ammonium. And so calcium with carbonate is low solubility, which tells me that if I have the compound CaCO3 as a product, it's going to be a solid, okay? Which means this is going to be the precipitate.
Oh.
Is that a little better?
Yeah. It's better.
Yeah, it's coming back?
Yes, it is. Thank
Okay, good. Yeah, no, it's been a long time, hey? It's been weeks and weeks. Okay. So if it's low solubility, it's going to be a solid. If it is soluble, it is going to be aqueous.
Okay, that makes it much easier to understand now.
Yeah. Oh, Quentin, I'm so sorry that you're not hearing this. Yeah, just go watch the video because, like, yeah, it can be really bad depending, on your connection and all that. Okay. So let's go back to our question. There we go. And I think we had actually finished that. Okay, so that is as complicated as it's going to get. If anyone wants, I can do another example. I'm not going to do one during this class, but if you guys request it, I can do another one and just post it up as a separate video. Okay? Because today I want to do something different. Today I want to talk about dissolving ionic compounds. Okay? And we are going to,